So it is abnormal. Clear na?
Yes, sir.
Okay. Any other doubt?
No. Thank you, sir.
Okay, beta. I am ending the meeting now.
Just give me a second, huh? You guys join. There is some technical error with this. Just give me a second. बताइए आप सभी, स्क्रीन क्लियर है सभी को? Is the screen is clear to you all and I'm audible to you? भाई रेस्पॉन्स हो तो जेएनवी एनएम के स्टूडेंट जैसे, ठीक है ना? इंस्टेंट रिप्लाई. I know कि one student is only answering in JNV NM school also, but it's really good to have uh, that kind of pace in the response. So we just start recording it. Okay. So good afternoon to all of you. I hope all of you are good, health-wise and mentally. Yeah. So this is our lecture number 9 actually, or 8. Okay. So in the previous session, what we have did in the previous session, if anyone remember what we have did, write it in the chat box. So in the previous session, the very important topic that we have learned is the when we take the dipole, electric dipole के बारे में we have discussed, and the motion of a charged particle. है ना? I hope you have remembered it and you have attended the lecture, making your notes properly, because they are ultimately going to help you, okay, in certain way, okay, in many ways. So taking up the class is the one part, and making the notes from the class what you have studied, that is the completion of the class. Okay, that is the completion of your learning. So when you are attending someone lectures, it's just not about me, any other teachers also I'm talking about. If you are attending the lecture any lecture, you are paying your 1 hour to them. So try to be extract more and more. Okay. Do not spend your 1 hour for nothing. Okay. At least after finishing of the lecture, you must know what the lecture is, what has been taught, what is the physical significance. These types of question must arise in your mind. Huh? So try to take the notes. When you're going to revise them, na, you would be having lots of question, lots of curiosity came in your mind that why is so? Why is that? Why is this? And when you encounter with these curiosity, full of curiosities questions, then you came up to the respective teacher and it will help you to dose your mind the lots of curiosity and lots of learning. Okay. So in the previous session, we have also seen one numerical, that what is the force applied by one dipole on the other dipole. Although we have discussed the one first part also, later on when we will discussing the when we are having the question discussion session, we will take all of these numericals, good numerical actually, and try to solve them and see the concept. Now in the today's class, the concept of electric flux we are going to dealing with, and continuous charge distribution. Now most of the students that are present here will be thinking like continuous charge distribution we have already covered. No, you have covered the types of continuous charge distribution, the how we can distribute the charge in how many ways. So we can distribute the charge. We will be having the situation when charge is distributed along a line, when charge is distributed along a sheet or plane of paper, or you can say along a plane. Okay. And we have also seen a case when charge is distributed along a volume, in the volume or throughout the volume. So based on these, we have three types of charge distribution: linear charge distribution, surface charge distribution, and volume charge distribution. Now, in this lecture, we are going to calculate the electric field due to the linear charge distribution. Okay. Suppose we have given some charge to a particular road. We having a road here and we are giving a charge to it. Then what is the electric field because of that particular road? Okay. So that we are going to cover. What is the electric field due to ring? If I just take a road and bend it into a ring, this is also a linear charge distribution. Hai. So what is the electric field due to that ring? That is also we are going to cover today. Okay. And the very important and very basic concept of, and that is going to really help you in Gauss law, the upcoming lectures, which is electric flux. Okay. So let's just deep down into it. I have given you the overview what we are going to cover today. Now just let's get started with it. Huh? Okay. So the learning objective of today's class is electric flux and continuous charge distribution. Now there is a psychology by keeping the title or keeping the learning objective short. Now, if I mention 5 to 6 point here, like we are going to cover this, and that, and this and that. And suppose there are 7 to 8 points that we are going to cover today. And I have mentioned all of that here. So in the very beginning of the lecture, you will feel demotivating. Oh my God, 6 to 7 topic we have to cover today. There is a lot to cover. So the real motivation of attending the full lecture is going vanish. So that is why this is the hack. And I already told you. No, I have told another students. Yeah. But I'm going to tell you also that when you mark up the heading now, when you are writing the properties, that these are the properties of, because you encounter this word very frequently, properties. So when you marking the properties now, you are writing down in your notebook. Do not write with numbers. Property number 1, property number 2, property number 3. Do not write in this way. always mark like this, stars, or keep it blank. Okay? Because in this case, na, when you mark with them my number, and when you are going to revise them, and suppose there are 10 properties, so you are, by looking at that, you will have a negative expression in your mind. Oh my god, I have to learn 10 properties. But when you don't see the number, na, mind cannot encounter that situation there. Okay? Okay, these are the stars, all the properties I have to learn. This is the thing. It makes your learning easier. Okay? So that is why I am keeping the title here very short, the learning objective. Okay? Any problem with the voice? Any problem with the screen? Any problem with the concept also, let me know in the chat box. I'll be there for you. Okay? Now, the electric flux. Up in the previous classes, we have dealt with the electric field lines. And what is the concept of electric field line? Okay, Sabrina, thank you so much. So what is the concept of electric field actually? Electric field somehow representing the strength of a charge, point charge. Basically, it is representing what is the strength of a point charge. Now, how powerful a charge is will be determined by this, by the electric field it is generating. Okay? More powerful, more is the strength of electric field, more is the powerful that particular charge particle is. Hmm? Because more powerfully it is going to attract or repel the other charges. Okay? So electric field is somehow related to the strength. That is why the another name of electric field is also electric field strength. Okay? But we cannot see it actually. We have to only visualize it. And to visualize the electric field, we have introduced a new concept. That is the electric field lines. Why we are drawing the electric field lines? Electric field lines we will draw. For point charge, it is radially outward. For negative charge, it is radially inward. For uniform charge or for uniform electric field lines, they are parallel to each other. है ना? ठीक है? These all we have things we have done. We have also marked up the property that if a curve of electric field line is this, and we want to know the direction of electric field, then that particular point pe we need to draw a tangent. And whatever is the direction of tangent, this is the direction of electric field. So electric field lines, let me write it here, that electric field lines help us in two way. First, to know the direction of electric field, and second, the know of strength of electric field. What is the strength of electric field? How powerful the electric field is. Okay? How? We have also seen that where the more crowded area of electric field lines is there, more crowded region, more will be the strength. Strength is more here. Less crowded area for same area of cross section. Dekho, I have taken the same ring here. Let me draw it like this. I am considering this particular cross section. When I take it here, it is covering the total 4 or 5 lines. Total 4 or 5 lines passing through this. Okay? But the same area of cross section, when I shift it here, only one electric field line is passing, which is telling us that here the strength of electric field is less, and here the strength of electric field is high. Got it? Okay? Which means it depending on some factors like the area that we have chosen. Suppose the area of cross section that we have chosen here I just extend it, make it big. So it is also capable of crossing all the 4-5 lines. ठीक है? Which means there is some quantity which is relating the area of cross section over which these electric field lines are passing. ठीक है? Because more of the electric field lines are passing through an area, more will be the strength of that particular electric field. ठीक है? Got it? So that particular quantity which represents the number of electric field lines passing through per unit area is termed as the electric flux. ठीक है? So electric flux का base I have already created. Why we are using electric flux? देखो, इलेक्ट्रिक फील्ड को इमेजिन करने के लिए, विजुअलाइज करने के लिए वी आर यूजिंग इलेक्ट्रिक फील्ड लाइंस. नाउ इलेक्ट्रिक फील्ड लाइंस का आउटपुट लेने के लिए, इलेक्ट्रिक फील्ड लाइंस को मोर यूजफुल बनाने के लिए वी आर यूजिंग इलेक्ट्रिक फ्लक्स. ठीक है? मोर द फ्लक्स इज विच मीन्स मोर द नंबर ऑफ इलेक्ट्रिक फील्ड लाइंस, और वाइस वर्सा. More is the number of electric field lines passing through per unit area, more will be the electric flux. I have already shown you. Now, suppose this is the uniform electric field lines. These all are parallel and equi-spaced. Equi-spaced mean इनके बीच में जो space होगा वो equal होगा. Any of two. कोई भी आप consider करो. कोई भी दो electric field lines लो, consider करो and measure the distance between them. It will be same. ठीक है? So that particular field is termed as uniform electric field. Now, what is the flux through the surface? So I have already told you that flux, this quantity flux is related to a particular physical quantity passing through per unit area. ठीक है ना? How much the quantity is passing through, that is termed as flux in the language of mathematics. ठीक है? Flux को you can also say fluid flux. How much quantity of water is passing through per unit area. ठीक है? That is called the hydraulic flux or water flux. So here we are interested in the electric field lines. So flux through a surface will become the number of field lines passing through it. ठीक है ना? इसे डिनोट किससे करते हैं? फाई से. फाई, FAI. ओके, फाई. मैं हिंदी में भी लिख देता हूं यहाँ पे, फाई. ओके, डू नॉट कंफ्यूज विद द टर्म्स. Suppose this is the area 1 that we have considered. This is area 2. So it is very clear that this area 1 is small in size. This area 2 is large in size, which means the probability of passing more and more field lines is higher in 2, lesser in 1. So the value of flux through this particular area is less and this particular area is high, which means that this flux through any surface will depends on the area of the surface. ठीक है ना? What is the area of the surface? देखो क्लियरली यहाँ पे दिख रहा है. ये एरिया क्या है? कम है, तो नंबर ऑफ फील्ड लाइंस पासिंग इज ओनली 1. ये एरिया ज्यादा है, तो नंबर ऑफ फील्ड लाइंस पासिंग इज 2. ठीक है? तो मोर विल बी द एरिया, मोर विल बी द वैल्यू ऑफ फ्लक्स पासिंग थ्रू इट. ठीक है? क्लियर है सभी को? Anyone any kind of doubt? If it is clear, then write clear in the chat box. Having any kind of doubt, write your doubt in the chat box. ठीक है? Now देखो यहाँ पे थोड़ा और क्लियर से समझने के लिए देखो, एज द फील्ड स्ट्रेंथ, सेकेंड फैक्टर जिसपे इलेक्ट्रिक फ्लक्स डिपेंड करता है. इलेक्ट्रिक फ्लक्स फर्स्ट किस पे डिपेंड किया? एरिया पे. सेकेंड किस पे डिपेंड कर रहा है? नंबर ऑफ electric field lines passing through that area, which means number of field lines क्या बताती है? More is the number of field lines, more will be the strength. देखो इस पर्टिकुलर वीडियो को दोबारा से देखो आप, देखो देखो जैसे जैसे लाइंस आर हैविंग लार्जर मींस field is getting less strength because area, देखो area is fixed here but the field lines are changing. ठीक है, अब फील्ड लाइंस क्या है? ज्यादा क्राउडेड है, लेकिन जैसे जैसे ये फील्ड लाइंस की क्राउडनेस बढ़ती हटती जा रही है, तो देखो जो ग्रीन लाइन है ना वो ही केवल पास कर रही है, विच मींस ऑन इंक्रीजिंग द स्ट्रेंथ the field, the flux value will increase because if we increase the field strength, number of field lines will also increase. More crowded, more field lines. Less crowded, less field lines. इस पोजीशन में it has maximum field because all the fields line are passing through it, this area. But when the field strength is decreasing, देखो number of field lines passing through this area is also decreasing. ठीक है ना? So that is why it depends on the electric field also. Now, if this electric field is strong, density of electric field lines is higher. ठीक है? So greater the number of field lines pass through the surface. Clear है? I think अब ये बहुत clear हो जाना चाहिए. So greater is the value of flux through the surface. ठीक है? जितनी फील्ड स्ट्रॉन्ग उतनी ज्यादा फील्ड लाइंस, जितनी ज्यादा फील्ड लाइंस उतनी ज्यादा वो सरफेस को पास करेंगी, और जितनी ज्यादा फील्ड लाइंस सरफेस को पास करेंगी उतना ज्यादा फ्लक्स हमें मिलेगा. ठीक है, मोर इज द फील्ड स्ट्रेंथ, मोर इज द नंबर ऑफ फील्ड लाइंस, मोर नंबर ऑफ फील्ड लाइंस रिजल्ट्स इन more number of field lines passing through the surface, and more number of lines passing through the surface means more value of electric flux. Got it? Now how it is depending on the area of surface, वैसे we have already seen it, but for your better understanding देखो, if we are decreasing the area, the number of field lines are also decreasing, number of field lines passing through this area is also decreasing, and as we increase the area, as the area is increased, so number of field lines are also increasing. ठीक है ना? So this will also depends on area of the surface. If area is small, number of field lines passing through is less, which results in small value of flux passing through it. ठीक है? So more is the field. In the previous case, more is the electric field, more is the electric field lines, more is the value of flux. In area, more the number of field lines, more the value of flux. Less area, less line, less field lines, less flux. ठीक है? So if the surface area is large, then flux passing through is also large. Got it? Now, the third thing that on which the electric flux depends on, the angle between electric field and surface. Look at this particular video and you will get to know how it will. Just a second. Yeah. थोड़ा डिस्टरबेंस हुआ होगा मेरी वॉइस में, है ना? So I am talking about the third factor on which the electric flux depend on. So electric fluxes depends on angle between the electric field and surface. देखो कैसे? Look at this video. As I am tilting this, you can easily see this. As I am decreasing the angle between the electric field lines and the area, we will also get to know how to find the area vector. ठीक है? Area is also a vector quantity. ठीक है? So more is the एंगल बिटवीन देम मोर इज द नंबर ऑफ फील्ड लाइंस आर पासिंग थ्रू इट। ठीक है, देखो, और अभी ऐसे रहने दो कि मोर इज द नंबर, मोर इज द एंगल, मोर इज द नंबर ऑफ फील्ड लाइंस। दिमाग में ये रखो कि चेंजिंग द एंगल विल चेंजिंग द नंबर ऑफ फील्ड लाइंस। ठीक है ना, easily you can see it when we are changing the electric when we are changing the angle between the surface and the electric field lines, the number of field lines are also changing। ठीक है, now this is the term for the mathematical expression of electric flux। I will tell you that how to find the area, and then I'm going to tell you that increasing or decreasing the angle as effect is how it is affecting the electric flux, increasing or decreasing the angle। But first of all, I'll let you know what is the how to find the area vector and what is the area vector actually। So here the phi is given by, phi is the electric flux. It is given by Es cos of theta. Got it? Now, Es cos of theta is nothing but we have seen a multiple time that A vector dot B vector is AB cos of theta. So it is Es cos of theta, which means it is the dot product of E vector and S vector, okay, which already convey you one very important information that this flux is a scalar quantity। ठीक है, because we know that the resultant of this dot product will give you a what, will gives you a scalar quantity। So this electric flux is a scalar quantity। Now where this S vector is the area vector, now here's the come the hacks how to find this area vector। ठीक है, so area vector is nothing but it is the perpendicular vector to a particular cross section। ठीक है, कोई भी सरफेस आपने ली, ड्रॉ अप नॉर्मल टू दिस सरफेस, ड्रॉ अप अ नॉर्मल, एंड दैट इज द एरिया वेक्टर। ठीक है, गॉट इट। सपोज दिस इज द सरफेस एस, this is the electric field lines passing through this। Now what is the magnitude of area vector? It is the magnitude of this area। ठीक है, now here's the come, what is the direction? So direction of area vector is always perpendicular to the surface। ठीक है, क्लियर है? So in that way, if you will see, if this is the surface, and let me show you in like this, just a second। If this is a particular surface, so unit normal vector to this surface will be like this। इसमें किसी को डाउट है? At 90 degree, but there could be a possibility that this vector can go downside also, this is also an at 90 degree। So which vector has to choose? Similarly, if I draw this is minus n vector। ठीक है, minus n cap। Why I am denoting it n cap? Because it is only denoting the direction। The magnitude of area vector is this, this is only representing the direction। ठीक है, got it? Clear है सभी को? But the direction will also possible in two way। Look at my hand, this is also a plane। Got it? And suppose this is the normal vector, it is coming out, first of all coming out, and इधर इधर से भी हो सकता है ना, ऐसे भी तो हो सकता है, दिस वे में। क्लियर इज क्लियर है? तो देर आर टू पॉसिबिलिटी, एदर आउटसाइड और दिस साइड। ठीक है ना? सो विच वेक्टर हैज टू चूज? तो ऑलवेज द पॉजिटिव वन वी हैव टू चूज। ठीक है, In case of open surface, this is a open surface. This is not a closed surface. Got it? So in case of open surface, the area vector, you can choose whatever you are aiming for, but you have to take the sign convention according to that. Okay? If you are taking this side as positive, so this side you have to take negative. Okay? Generally, we will consider this axis as positive x-axis, this axis as negative x-axis. So we always try to be positive. That is why we choose the direction in the positive direction. Okay? Choose the direction of this area vector in positive. Got it? Now, so direction can be n cap or minus n cap. ठीक है? N cap is the normal vector. Always remember. Surface के क्या होना? Perpendicular होना. ठीक है? Now, if electric field is non-uniform, let's say, non-uniform होने से क्या होगा? If the field is uniform, just let me change the screen here to make you understand in a more detailed way. Suppose these are the field lines passing through this surface, and these are the uniform electric field lines. So, जो फील्ड लाइंस यहाँ से पास करेगी, सेम ही फील्ड लाइन यहाँ से भी पास करेगी, बिकॉज दे आर द सेम लाइन. गॉट इट? गॉट इट? एंगल भी जो इसके साथ होगा, इसके साथ भी वही एंगल होगा. हाँ, बट what if the field is like this? Field is like this, and area vector, area you have chosen like this, area is this. So इस फील्ड लाइन का, this one, इस फील्ड लाइन का जो एंगल होगा वो अलग होगा, इस फील्ड लाइन का जो एंगल होगा वो अलग होगा, इस फील्ड लाइन का जो एंगल होगा वो अलग, which means that is a non-uniform electric field. In that case, we cannot apply the expression of electric flux this way directly. So for that, what we have to do, we have, suppose this is the surface we have, ठीक है? इससे electric field lines are passing in random direction, which means the electric field lines are non-uniform. So what we'll do, we will consider a very small area on the surface of this particular conductor. Very small area of ds we will consider. Okay? And we mark that this area vector should be perpendicular. Okay? This is the normal vector of this. We can also direct it like this, ds vector. And the angle between electric field and this is theta. This is electric field. Okay? So now, what is the value of electric flux? If area is very small, so the value of electric flux is also very small. So d phi we will write it as, ठीक है? d phi का मतलब होता है very small. ठीक है? d phi is equals to E dot ds. When you integrate it over the entire surface, you will get to know the value of total flux. Okay? So that is why in this expression you can see, if electric field is non-uniform, it is given like E vector dot ds vector. Okay? So take the note of it. ये सब मैं आपको बता चुका हूं. SI यूनिट you must have to note. ठीक है? Take a note of it. And give me few minutes just to... So, have you noted down? All of you noted down? JNV, Yanam, and any other students? Sabrinath, Ashwin. What about others? Any kind of doubt you guys having? Till now it is clear to all, na? Okay. Let's move. Area vector for closed surface. तो surface क्या हो सकती है? Closed भी हो सकती है. You can have a sphere. You can have a cube also. So in this case क्या हुआ? Every surface is closed. You can see here. So for closed surface, area vector always you have to take in the outward normal direction. ठीक है? Always take area vector in outward normal डायरेक्शन. ठीक है, हमेशा बाहर की तरफ. आउटवर्ड परपेंडिकुलर, नॉर्मल माने परपेंडिकुलर टू द सरफेस. ठीक है, so for closed surface area vector is always taken in the direction of outward normal to the surface. Got it? Now this is the question for you. If the electric field is given to be 5i cap 4j cap plus 6k cap. देखो, if you have pay attention in the 11th class vector chapter, ठीक है ना, starting में we will deal with vector, cross product, dot product. So that particular learning of the 11th class will ultimately going to help you in 12th class. ठीक है, so there is nothing wasted. You have to utilize that particular concept or the asset that you have learned in the 11th class. ठीक है, so who knows how to multiply the vector in dot manner and cross manner would able to answer this question. So in this electric field is given as 5i cap 4j cap plus 6k cap, and area vector s vector is given as I cap 2j cap plus 3k cap. Now what has been asking? What is the electric flux? Very simple question I have taken. Electric flux will be E vector dot S vector, which means 5i cap 4j cap plus 6k cap dot product with I cap 2j cap plus 3k cap. Now we know the resultant of this dot product. You just have to multiply the same vectors. I cap की multiply I cap के साथ, j cap की multiply j cap के साथ with the coefficient also, and k cap multiply with this k cap with the coefficient. So 5i cap I cap will become 6, 4j cap 2j cap will become 8, 4 to 8, j cap will become 1, and this 6k cap and 3k cap will become 6 3s are 18. So this will become 18, 18 plus 8, 24, 5 into 1 is 1. Oh, I'm so sorry. I have considered it at 6. 5 into 1 is 5. Very good. So it came out to be 31. Very good, JNVNM student. Very good. Okay. 31 with the unit itself. And what should be the unit? It is E dot S. So you can put the value of electric field unit, which is Newton per what? Coulomb into area. So Newton per coulomb into meter square. So you can take this unit also, Newton meter square per coulomb. ठीक है ना? Clear है? Now move on to the next slide. ये इसका ऐसा solution है, वही same चीज है. This one, try to solve this also. Try to solve this. Charge q is placed at the center of a sphere of radius r. Find the flux of the electric field through the surface of the sphere due to the enclosed charge. So देखो q charge है, either you can consider it positive or you can consider it negative. ठीक है, so we will be considering it as a positive charge. ठीक है, and this is placed at the center of a sphere of radius r. Suppose this is the sphere, not the perfectly one, but you can consider it, and here the positive charge we have placed. ठीक है, the radius of this circle is capital R. Now what is the field? We know that due to this positive charge, this point positive charge is a point charge. Point charge say what is the electric field? Electric field is radially outward. Okay, so these field lines will be passing radially outward because of this point charge. So can any one of you can tell, is this field, whatever the field is E, is this uniform or not uniform? Anyone? Can anyone tell whether this field is uniform or not uniform? Very good, JNVNM student. Very good. Keep it up. What about others? What about you guys? Ashwin, JNV Ahmednagar. This will be non-uniform. You can see here. At each point of time, you can see here. Okay, na? Area is also changing. Area is also changing. And the field direction is also changing. So this is not a uniform electric field. Because for uniform electric field, the electric field line must be parallel to each other and equispaced. And these are not parallel, not equispaced. But a really interesting thing that you can note it here is that if you consider this particular area, na, this is a very small area, ds. And we know that area vector will be normally outward. Okay. This is a closed surface, so it will be a normally outward vector. Surface के क्या होगा? Outward होगा. So this is area vector, ds vector. This is electric field. Got it? Now, what is the angle between area vector and electric field? Can anyone tell what is the angle between electric field and area vector here? Any one of you? This is the field, this is area vector. नहीं, 180 कैसे हुआ? This is 180, this is E and इसी डायरेक्शन में क्या है? ds है, so it should be 0. Very good. ठीक है? Now देखो सेम चीजें इसने बनाई हुई है, तो हम यहाँ पे क्या करेंगे? Because this field is not uniform, so the flux will be d phi is equals to E vector dot ds vector. ठीक है? Got it? Now d phi को इंटीग्रेट जब हम करेंगे, so we will get E dot ds vector. ठीक है? Got it? Clear है सभी को? Everyone clear with this expression? Clear है ना? Now अब E वेक्टर डॉट ds वेक्टर को ओपन करेंगे, so it will become E ds cos 0, and cos 0 is nothing but 1. So this is came out to be E dot integration of ds. E को बाहर ले लिया, because for this particular value of cross section E is not changing, है ना? स्मॉल एरिया के लिए E तो सेम ही है, so E को we can take common out. Now इंटीग्रेशन ऑफ ds का क्या मतलब हुआ? इंटीग्रेशन ऑफ ds का मतलब हुआ वी आर समिंग आउट द टोटल एरिया ऑफ दिस सर्कल. ठीक है, over this entire surface we are summing it out. ठीक है, got it? And that would be come out as, what is the surface area of this sphere? This is a sphere. Surface area of a sphere is 4 pi r square. So it will become E into 4 pi r square. But can we also put, very good, can we also put the value of E? Because E is due to this point charge. और point charge से field क्या होती है? K capital Q upon, यहाँ पे हमने small q consider किया था ना, तो K small q upon r square. इस पर्टिकुलर पॉइंट पे बात कर रहे हैं, दिस पर्टिकुलर पॉइंट. ये पॉइंट कितनी डिस्टेंस पे है? कैपिटल आर डिस्टेंस, कैपिटल आर डिस्टेंस, तो के क्यू अपॉन आर स्क्वायर. ठीक है, इसी पॉइंट को पूरे में घुमा दिया, पूरे इसका आ गया ये 4 पाई स्क्वायर. ठीक है ना, मल्टीप्लाई विद 4 पाई आर स्क्वायर, व्हेन दिस विल कैंसिल आउट. ठीक है, दिस the value of k you can also put it down, 1 upon 4 pi epsilon naught. 4 pi and 4 pi will cancel out. So the flux due to this point charge, which is kept inside a sphere, is coming out q upon epsilon naught, which means you just have to consider what is the charge enclosed inside it and divide it by epsilon. ठीक है, क्लियर है सभी को? आई होप दिस इज क्लियर टू एवरीवन. क्लियर है? एनी काइंड ऑफ डाउट गाइस? Put a yes and no in the chat box. Okay. Now, continuous charge distribution. तो एक recap दे लेते हैं. तो continuous charge distribution क्या है? Continuous charge distribution of a system in which charge is uniformly distributed over the conductors. ठीक है. So in this system, infinite number of point charges are closely packed and have very minor space between them. I have already told you that that particular space is negligible. ठीक है ना? So types of continuous charge distribution में we encountered three continuous charge distribution, that is linear charge distribution, surface charge distribution, and volume charge distribution. Linear charge distribution means it is given by lambda is equals to Q upon L, and where lambda is the anyone linear charge density when charge is distributed over a length. ठीक है, surface charge में we will use sigma. Sigma is nothing but Q upon area, charge per unit area, and this is called surface charge density. Got it? And then we have the volume charge distribution, which is given by rho Q upon V, charge per unit volume, and it is nothing but the volume charge density. Volume charge density. ठीक है? Now, अब क्या करेंगे अपन? We will introduce the expression of electric field due to this line charge. ठीक है? So we have distributed the line charge positively. A positive charge is given to this. ठीक है? If you take this as a conducting rod, so this charge will lie on the surface of it. If you take this rod as non-conducting, so this charge will be inside the surface. ठीक है ना? सरफेस पे चार्ज नहीं हो, जहां दोगे वहीं पे रुक जाएगा. ठीक है, तो we will considering it as a conducting rod. This is x-axis, this is y-axis. अब कंटिन्यूअस चार्ज डिस्ट्रीब्यूशन तो हमें नहीं पता व्हाट इज द इलेक्ट्रिक फील्ड, हाउ टू कैलकुलेट इट. किससे पता है? पॉइंट चार्ज से तो पता है, लेकिन वी नो द एक्सप्रेशन ऑफ इलेक्ट्रिक फील्ड लाइंस फ्रॉम अ पॉइंट चार्ज. ठीक है, so we can easily calculate if I get to know. So what will I do? I will make this particular road as a point charge. कैसे? Suppose I have to find the value of field at this particular point P. This is the point P where I have to find the field due to this line charge, and the length of this road is L naught. ठीक है, और L ही लगते हैं, L. ठीक है. By this end, from this end, the value of distance between this point P and this the very end is, let's say, x naught. Okay. So what we have considered that at a particular distance x, there is a very small charge dq. This green color box you are seeing, this is very small charge, very small charge. And if it is a very small charge, can we consider it as a point charge? Yes, this is a point charge. So this point charge having magnitude dq. कितनी लेंथ तक है ये? dx लेंथ तक है. dx is also very small. जब लेंथ ही बहुत कम हुई, dx is very small, तो उस लेंथ पे चार्ज कितना होगा? वो भी बहुत कम होगा. very small charge. ठीक है. अब this particular section will behaving as a point charge. Point charge से किसी particular point P पर what is the expression of electric field? Can we write it down? So due to point charge dq, field at point P is given by what? I hope आप सबने अपनी नोटबुक में पहले ही लिख लिया होगा. DE is equals to, अब ये फील्ड भी क्या होगी? बहुत कम होगी. जब चार्ज ही बहुत कम है तो फील्ड की वैल्यू भी क्या होगी? बहुत कम होगी. So it is given by k dq upon the distance from the charge, and the distance from the charge is small x. K dq upon x square. This is equation number 1, because we know that for a point charge, electric field is given by k capital Q upon r square. ये याद रखना. तो चार्ज क्या है हमारे पास? dq है. डिस्टेंस कितनी है उस चार्ज से उस पॉइंट की? is x, so it is x square. ठीक है. Now अब we are going to use the linear charge density. ठीक है, कुछ तो यूज होना चाहिए ना उसका. बिकॉज अभी तक हमने किस लेंथ के लिए निकाला? किस? इस पॉइंट चार्ज के लिए देखा. हमें देखना है इस पूरी रोड के लिए. एंड दिस पूरी रोड, दिस कंप्लीट रोड is what? A linear charge distribution. So we have to apply some mathematics. Now this dq charge is distributed over a dx length. So what is the linear charge density then? Linear charge density is nothing but dq over dx. Okay. So can we not write this dq in terms of charge density? क्या ऐसे नहीं लिख सकते? dq is nothing but the charge per unit length into length. देखो इस पूरी रोड पे लेट से प्लस q चार्ज इज गिवन. ठीक है. सो चार्ज पर यूनिट लेंथ वी कैन इजीली कैलकुलेट. इट इज सेम एज वी डिड फॉर द bananas and for the oranges. So suppose you know the price of 10 orange, you can easily find out the price of 1 orange. And when you know the price of per unit orange, you can calculate it for any number of orange. ठीक है ना. अगर 10 ऑरेंजेस का प्राइस 100 रुपए है, 100 रुपीज, सो 1 ऑरेंज का प्राइस कितना हुआ? 10 रुपीज. अब 1 ऑरेंज का प्राइस 10 रुपीज है तो 1000 ऑरेंज का कितना हुआ? 10,000. 180 oranges का कितना हुआ? 1800. So how you are able to do this? You just multiplying this one orange का price with the number of oranges. In similarly, we are doing here, there's this lambda is nothing but the charge for this unit length, per unit length. ठीक है? This lambda is nothing but the charge per unit length. Now for how much length we need to know the charge for dx length. So what we are going to do, we just multiply with it. This will become lambda into dx. Put the value here. So d will become k dq is lambda dx divided by x square. So d will become lambda k lambda dx over x square. Now this is small d. To calculate the total value of electric field, we have to integrate it. When you integrate it, this k lambda will came out because k is constant, lambda is constant. Okay. Now this is the terms for limit. From where to where this charge is distributed. तो देखो इस पर्टिकुलर पॉइंट P को कंसिडर करो बिकॉज यहाँ पे हमें चार्ज सॉरी फील्ड की वैल्यू देखनी है. तो यहाँ पे जो फील्ड आ रही होगी वो यहां से शुरू हुई होगी जहां से ये लाइन चार्ज डिस्ट्रीब्यूशन शुरू और यहां तक का चार्ज इज डिस्ट्रीब्यूटिंग इज कंट्रीब्यूटिंग एट द फील्ड एट पॉइंट P. ठीक है, मतलब इस एंटायर लेंथ का चार्ज आ रहा हो. इस पॉइंट P से इस पॉइंट की क्या डिस्टेंस है? x नॉट, विच मींस x नॉट से शुरू हुआ है और कहां तक है? x नॉट प्लस l तक. कंप्लीट लेंथ कितनी है? l. So upper limit will be x naught plus l. Now do this calculation on the next page. So this will become integration of d is equals to x naught to x naught plus l. जहां तक चार्ज डिस्ट्रीब्यूटेड पॉइंट P से, ठीक है. So it will become k lambda आउटसाइड में रखेंगे 1 अपॉन एक्स स्क्वायर इंटू dx. 1 अपॉन एक्स स्क्वायर का इंटीग्रेशन क्या होगा? एनीवन? -1 अपॉन एक्स. ठीक है, x नॉट टू x नॉट प्लस l. Now k lambda, put the limits here. When you put the limit, this will come as negative -1 upon x. x की जगह पे क्या रखेंगे? पहले अपर लिमिट x नॉट प्लस l. Let me do it here to avoid any kind of confusion. x नॉट प्लस l minus of, because it is itself is -1 by x, minus of x naught when you put the lower limit. So finally, this will came out to as k lambda into this minus and minus would plus x naught minus 1 upon x naught plus l. Take the LCM here. It will become k lambda x naught plus l minus x naught divided by x naught into x naught plus l. This will cancel out. And if anyone guess what is this term lambda L? Can anyone tell? Lambda क्या था? Linear charge density multiply with entire charge, entire length. तो क्या मिल गया? Total charge. ठीक है ना? So this lambda L is nothing but the total charge. So we can write the electric field vector is K capital Q over x naught into x naught plus L I cap. I cap क्यों है? देखो पॉजिटिव चार्ज था, फील्ड की डायरेक्शन अवे फ्रॉम द पॉइंट, अवे फ्रॉम द पॉइंट चार्ज, एंड दिस डायरेक्शन इज व्हाट? एक्स डायरेक्शन, एंड एक्स डायरेक्शन का यूनिट वेक्टर इज. ठीक है, क्लियर है सभी को? एवरीवन, इज दिस क्लियर टू यू ऑल? यू कैन राइट इट हियर, दिस लैम्डा एल इज कैपिटल क्यू. ठीक है, तो आज यहीं तक रखते हैं लेक्चर. थैंक यू सो मच फॉर बीइंग अटेंटिव and being responsive. If anyone has any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive. Okay. Bye. Take care. Bye, guys.